It doesn't all fit on one page on the screen. I'm sorry, everyone. But there is 1, 2, 3, 4, 5, 6. Oh, 6 is 7 is 25, I believe. $25. And then 34 for 8. And then 9, 10 right there. 10.6, 8.1. 8.7, 13.4, 15.6, 15.7, 29.3, and 36.7. If you do not have the right answers, that is okay because it is being recorded and you can go back and check on YouTube later at your leisure. Do not try to copy down all the right answers right now because I will be moving on. All you should be doing is looking down your work and going tick, tick, X, X. If it's blank, obviously, man. Everybody good? Spectacular. Turn the page over and here's the next one. You can do the top 4 right there because they fit on the screen. Oh, and by the way, of course, if you need any of them explained, what should you do? Ask. Everyone good? Super duper. And then there's the bottom 3. Yes. Number 3, sure. So he needs, how much fence does he need to go around the whole garden? 4, 5. So all I need is that, which is the square root of 4 squared plus 5 squared, which is the square root of 16 plus 25, which is the square root of 41, which is about 6.5. Then you just add it all up. That's no good. So whatever that is, square root of 41, yeah, it's about 6.5. Everybody good? Once, twice, thrice. Pythagoras is now your friend. Which number where? 16 plus 25. Because the 16, 4 squared is 16, 5 squared is 25. Everybody good? Spectacular. Please turn to page, I don't know what page number it is. It is page 53. Now I need you to do me a favor. There's a slight misprint here. Take this little dot by C and move it up 1. So it's by the letter C. Pretend this little dot's not even there. Okay? Okay. All right. We are not going to break out rulers. That's no big deal. We are moving into the study of trigonometry. Trigonometry is the study of triangles, their angles, and their sides. In the 10th grade, we only deal with right angle triangles, which is why I spent so long on Pythagoras. Everybody cool? All right. Now, you do not need to use a ruler to do this. I am going to just freehand this first red triangle. Oh, that was a horrible one on the bottom there. Ooh, what an idiot. If you have different colors, it might help you, but you do not need them. All righty. Now, knowing what we know from yesterday, this is angle A, yes? Which makes, what are the 3 names I could give this side? FB, BF, or little a, right? We're all cool with that from, maybe not yesterday, it was the day before, I don't remember. Well, the day before was Sunday, it was yesterday. Yeah, okay. So now, I want for you to make a ratio of these line segments, BF to AF. So how long is BF? 3. How long is AF? 4. Everybody cool? So if I was going to write that as a ratio, BF to AF, BF goes first, then AF. Everyone understands that, right? It's back in the day, you learned ratios in like grade 5, and your teacher always used the same kind of ratios. People wearing black shirts to people wearing blue shirts. People with glasses to people without glasses. Kids in the room compared to adults in the room. You all know how to do ratios. What's the other way we write ratios? Not horizontally with a colon. As a fraction. So this is also 3/4 or 4/3? 3/4, because the first number is the numerator. 3/4. Agreed? What is another value for 3/4 that we use all the time? 20. Yeah, thank you. 75%. And one more. A decimal, and what would it be? 0.75. Is everybody cool with that? Excellent. Now, all of you, please be aware that right here we have an angle, yes? That angle is angle A. Everyone's on board, right? Now, do we know the angle here? What is it? 90. So if we knew angle A, we would automatically know angle B, wouldn't we? Why? Because the triangle angles add up to 180. Everybody cool? All right. Now, I'm going to change color to purple. I'm going to go all the way out to G and all the way up to C. And now, what do I get? What's changed? The scale of the triangle. Has the angle changed? No, it is still angle A, isn't it? What is the ratio now? The bottom one is 12, so AG is 12. That's the second one. What's this one? 9. Now you guys and ladies are intelligent people. 9/12 is what? 3/4, which is 75% and 0.75. Agreed? Easy peasy, yeah? Sides changed, angle didn't. All good? Okay. I'm going to change colors to orange. Did the angle change? No. Did the sides change? Yeah, they got bigger. What's this comparison? $20. And what's the vertical one? $15, which is 15 over 20, which is 3/4, which is 0.75. Everybody cool? What would happen if I took this orange line and drew it all the way over to that wall? And then I took this orange line over there from a 90 degree and drew it all the way over to that wall. What would happen if I divided those two numbers? What would I get? I would get 3/4, no matter what. Does this angle ever change? No. So the size of the legs of the triangle, the sides of the triangle, because that's not a leg, doesn't affect the size of the angle. Everybody follows this? So the general statement we can make is, if I compare the two legs, remember, not the hypotenuse, if I compare the two legs of a right angle triangle, the ratio will stay the same if the angle doesn't change. A-N-G-L-Y. Angle does not change. So, what this means, if I were to draw a blue line right there and there, what do you automatically know, if that's X and that's Y, what do you automatically know x divided by y is? 3/4. Or 0.75. Or any of its other fractions, right? Right? It could be 12/16, correct? Everybody cool? No matter what. That, ladies and gentlemen, is part of the scale thing we were talking about, which is part of why we're able to build buildings like this from a plan that's this big. Everybody cool? All right. Now, I have decided on a new policy. It is not fair of me to expect you people to pay attention for 60 straight minutes. You've been paying attention for a good long time. You have 2 minutes to talk amongst yourselves. Go. You have 2 minutes. It's already started. Go. You have 2 minutes. It's already started. Go. You have 2 minutes. It's already started. Go. It took 1 minute to decide they needed to walk. In 1 minute, I'm going to go close the door. I won't lock the door, but the next time I do this, I will. My day is going very well, Jyotika. How is yours? Spectacular. What's tiring? Sitting in one place all day? That's backbreaking, man. How are you going to make it through? Right, I get that a lot. I'm pretty boring. Out of time. What's the number one way to lose a privilege? Then not do it, right? If you can't tell 2 minutes of time, you shouldn't have left the room.
Well, I didn't know what time it started.
I will, of course, be giving you one more chance to screw up before I take that privilege back. If you cannot tell how long 2 minutes is, I would not recommend leaving the room, because the next time one person is late, the privilege is gone. Yes. Why do you think I was at the door, and why do you think I am saying this? Do you hear my own voice? You carry around something that tells time. You should probably check it. Because when I say 2 minutes, I mean 2 minutes. If you're going to take a minute to get off your ass to leave, that's half your time gone. This ratio, ladies and gentlemen, is called the tangent ratio. And that tangent ratio holds true for all. Please underline all. Right triangles. And it is the comparison between the two legs, not the hypotenuse. Everybody cool? All right. Now we are going to have the most difficult moment of the year so far for me as a math teacher. Every single one of you, and it won't be possible because a bunch of you still don't have calculators, every single one of you look at your gray calculator screen. Right now, after you push the clear button, you should see a 0 right there. Right? Some of your calculators will have some other stuff on them. I don't care about any of it except this. Somewhere on your calculator, you need to see the letter D or the three letters D, E, G. If your calculator does not show D or DEG, if it doesn't show that, put your hand up. D or DEG. If it does not show that, then put your hand up. What does yours show? An R or the word RAD? I'm not talking to you, crap. It shows an R or an RAD? Okay, somewhere on your calculator, there should be a button that says DRG, and it might have an arrow. Push that button until it says DEG. That's fine, as long as it says DEG. Everybody has that? Okay, that is problem 1. You cannot do trig, this entire unit, in this room, if you don't have DEG showing on your calculator. It stands for degrees. It means it's going to do all your trigonometry calculations in degrees. There's other ways we measure angles. You don't have to care about them till grade 12. But in grade 10 and 11, we use degrees. If you look at your calculator and it is not showing DEG or D, you push that button until it does. Everybody cool? If you ever get out of degrees and you can't find that button, come and see me and I will very pleasantly fix it for you the first time. Everybody cool? All right. Now the next thing we have to, remember how yesterday we were talking about square roots and if you had a forward or a backwards calculator? Know what kind of calculator you have. Remember, a forward calculator, if I wanted to know the square root of 64, a forward calculator, you would push the square root button, then 6, then 4, then equals. That's forward. A backwards calculator, you would push 64, square root, and you don't have to hit equals. Does everybody know what kind of calculator they have now? Excellent. Now I want everybody to do these 3 steps. On your calculator, there are 3 buttons. They say sin, cos, and tan. I only want you to push the tan button. If you have a forward calculator, you are going to push tan, 3, 5, equals. And then you're going to get a big long decimal. If you have a backwards calculator, you're going to push 3, 5, tan. And you're not going to push equals. And you're going to get a big long decimal. What is that big long decimal? Just give me the first 3. 0.700. Everybody should be looking at that on their calculator right now. That means you know how, if your calculator is forward or backwards, and you are in the degree mode. Is everybody looking at 0.700? Yes! First try. You guys are on a roll. Nobody painted the roof, the door. What's next? What is this decimal? 0.267. Everyone agree? Okay. And what is 45? 1. Is everybody cool? All right. Now, remember, if I draw 3 right angle triangles below your decimals, so you should be all looking at something like that. Everybody is? This is what as a fraction? Did any of them work? Well, if they didn't work, I'm going to have to get rid of them. Son of a bunch of savages in this town. What is this as a fraction? 700 over 1,000. On this triangle, where would the 700 be? This is the angle A. Where would the 700 be? Look right up here. Look at the fractions. Make a connection from 5 minutes ago. Where is the 700 going to be? It's the height. Where is the 1,000 going to be? On the bottom. What would this one be? As a fraction. Over 1,000. Where's the 267 go? Where's the 1,000 go? What if I told you this was 26.7? How long would this be? 100. What if I told you this was 2.67? What would this be? 10. Does everybody understand? Everybody cool? All right. So this is 1. What's 1 as a fraction? 1 over 1, or 1 over 10 is 1/10. 1,000 over 1,000, or 22 over 22. Anything like that, right? So what does this tell you about these two sides? They got to be the same. If this is 45, this is 90, that's 45. Those two angles are the same, these two sides are the same. Is everybody good? Everybody understands? All right. Turn on to page 54, please. We are going to work in reverse. This is a decimal, yes? Everyone agrees, right? How could I write it as a ratio if I wanted to? I could write 3 over 4, 75 over 100, 7.5 over 10. Everyone's good, right? All right. Now, our calculator was able to give us a decimal when we gave it an angle, right? We just did that 3 times. We told the calculator that we had an angle of 35, and it told us, well, that means your triangle would go up 700 and out 1,000. Everybody understands, right? Okay. What is different here? I already have the decimal. So my calculator can tell me if I have a triangle that looks like this, it can tell me how big this angle is. Now, we just did this triangle, didn't we? It's a triangle we started with, right? Went out 4, up 3. We never found out what A was, did we? But now we're going to. Look on your calculator, not on the buttons. On the calculator, right above tan, you see this. Right? -1 is opposite, isn't it? So if pushing tan got me my ratio, what must the opposite operation be? It'll reverse tan and it will get me the angle. Nothing changes except I need to hit the button on my calculator. Some of your calculators say second. Some of them have an S for shift. Some of them might have INV for inverse. That should cover all your calculators. Otherwise, it's the exact same thing. So when we were doing the angle, if you had a forward calculator, you pushed tan 3/5 equals, right? So now if I'm going backwards, what do you think I push? I push, no. I push shift, tan, and then I can put either the fraction, 3 divided by 4, or I can just put the decimal and then equals. If I have a backwards calculator, it's reversed. I go 0.75, shift, tan. And I don't need to push equals. What is this angle? 36.86. Angles, and here's something many of you probably don't know, angles are measured like time in minutes and seconds. So we don't use decimals for them. Just round them off. to the nearest whole angle. So what is this guy? 37. So what is this angle here? 37. And trig helps us because if we ever have two things that are 37 degrees apart, we can then know how far apart they are because it will always follow that decimal. Everybody cool? It's actually how we tell how far away stars and things are. We use trig. Everyone good? All right. So knowing what you know now, ignore this negative sign. It's there. I don't even know why it's there. Tell me what this angle would be. The triangle would look like this, and it would be 123 over 100, wouldn't it? Taller than it is wide, right? So tell me what that angle would be. 51 degrees. Yay! Tell me what this angle would be, and tell me what the sides could be. What could I write here?
25.
25 over 10. What would that angle be? 68. Everybody cool? Every value of angle from 0 to 90 will give you a different decimal place. Nathan. 123 over 100 would be 1.23 if I was going back to the fraction. I did shift tan 1.23. You have a forward calculator, so you're going to go second tan 1.23 equals. Everybody good? Now I want you to notice something. We were always looking at this angle, weren't we? And we were always comparing that side to that side, yes? We never touched the hypotenuse, agreed? So I was comparing that side to that side. I was comparing that side to that side. And we were able to find this angle, weren't we? Well, what would happen if I didn't know this was 68, but I wanted this angle up here, and it was 25 and 10? What would I compare? Look what I did 3 times. Did I ever use the hypotenuse? It would be 10 over 25 because I'd use that one, then that one. What do you notice about all these arrows? I have an angle that I care about, and where did I go? To get the first number. I went across, or opposite. Where did I go to get the second number? Right beside it. Don't give me away yet, Jordan. Did I ever touch the hypotenuse? No. So, for any angle in a right triangle, the tangent ratio always compares the opposite. Leg or hypotenuse? Leg. Opposite leg. And what does opposite mean in trigonometry? Across. It compares the opposite leg to the, this is a new word for many of you, adjacent leg, which is the other leg, not the hypotenuse. Tangent is never the hypotenuse. Is everybody cool? Everyone is good? All right, you got 2 minutes. Starting now. You made too much noise in the hallway. If you make that much noise in the hallway, I'm bringing back my privilege. It's short for tangent. It is hard to find your mode. You need to go mode, down to degree. Now it will work for you.
I've tried that, but it won't work on the second stuff that we just did.
What second stuff?
This stuff.
Which, this?
Yeah.
Sure it will. Second, tan, 0.75 equals.
So I'll have to hit second.
Yes. That's shift. Okay. So in this, were you able to get,
Like I just couldn't.
were you able to
figure
get these?
out- I just couldn't figure out the two.
Okay.
Second.
So you, with the second one, so you were able to get all these decimals. So you were able
No,
to
I
get 10,
couldn't find-
15.
Yeah, like I did the 10
Yeah,
part. I
okay.
just couldn't find the second.
So you need to do the shift. So when you, second F.
Oh.
So second F, tan, 0.75,
Okay.
37. Now, if you don't have the decimal, that's what we're going to do next. Just, I'll show you that.
For like, you know how you got 0.7, there's 0.75.
Mm-hmm.
So you want to just get to a whole number, so that would be the bottom of the gun. But I don't know how you got the 75.
No, the calculator knows it's 0.75. That's what we did right here, right?
Yeah.
We did, it was 3/4, which is 0.75. It was 9/12, which is 0.75. It was 15/20, which is 0.75. So no matter what I do, no matter what calculator no matter how big a triangle I make, if this is 37 degrees, then it's always going to be 3/4. That's how trig works.
Yeah, I see how you
Oh, much better, ladies and gentlemen. They got 30 seconds to get back in here. Hey, why do you know this already? Oh, okay. Uh-oh. Doesn't look good. As soon as that goes to 210, I'm closing that door, and that's going to be your last chance. Well, that'll be the second strike. I'll give 3 strikes because I like baseball. Oh, strike 2. Damn, man. That sucks. All right. Now, ladies and gentlemen, here's a triangle, yes? Where is angle A? Right here, agreed? Now, if I want the tangent of angle A, the tangent of angle A is always the opposite divided by the adjacent, yes? Well, what number is opposite to angle A? 12. What number is adjacent to angle A? 5. That's strike 2. Okay, that's strike 2. 12 over 5. What happens if I move down here to B? Does the tangent of B still equal opposite over adjacent? Yes. What is opposite to B? 5 over 12. Does everybody understand? Opposite and adjacent changes depending on which angle you are using. Everybody cool? All right. Now, do I have the ratios? Okay. How will I use those ratios to find the angles? Is that tan or shift tan? Shift tan. So for angle A, I need to do shift tan of what fraction? 12 over 5, right? If I wanted to do B, it would be shift tan of 5 over 12. Use your calculator to figure out how to do this. We have only done this when I've already given you the decimal. So what are you going to do to figure this out? What is 12 fifths? 2.4. What is 5/12? 0.041. Now it's super easy, isn't it? Now, allow me to offer you this. This step right here, you do not need to do. Your calculator is smart enough to do it. If you have a forward calculator.
That's 0.41, not 0.04.
Oh, it's 0.41? Yeah, of course it is. He said, yeah. All right, now, if you have a forward calculator, your calculator can figure this out. You would push shift, tan, bracket, what? 12 divided by 5, close brackets, equals. What would I push over here? Same thing, except it wouldn't be 12 divided by 5. What would it be? Shift, tan, bracket, 5 divided by 12, bracket, equals. Because some calculators force you to close the bracket, so you got the wrong answer. So you might as well get in the habit of closing the brackets. So if you ever have to change calculators, you'll always close them. Now, what if I had a backwards calculator? I would reverse it. 12 divided by 5 in brackets, shift, tan. Now, for whatever you had on your calculator, write it down here the way you did it. So you don't need to consistently ask me, your neighbor, or yourself, oh my God, how do I do this? Because you're going to write it out right there. We are going to finish when we do these 3 questions, and you're going to be left with no homework. Yep. Has everybody written out their words? Spectacular. Now I'm going to show you something new that many of you will not have seen before. Everybody draw a circle and put a line through the middle of it. So it looks like that. That's a Greek letter. That is the Greek letter theta. It is the Greek letter T. That is the letter that for whatever reason math guys have decided is going to be the letter that describes an angle. If you're going to be talking about any angle in a triangle, you use that symbol, theta. Everybody cool? All right. So in this triangle here, am I looking for a length or an angle?
An angle.
I'm looking for the angle because that's where the x is, right? All right. So the angle I care about is theta. Does it have a value?
No.
No. So what do I write there? Who? Yen. Oh, no, he's in. Yeah. This is the angle I care about, yes? And what is that compared to this angle? Opposite or adjacent? Opposite. So my opposite is what value? 23. What is this 15? Adjacent equals 15. Now, I don't know the angle. Am I going to be using shift tan or regular tan? Shift tan finds angles, yes? So I know that tan equals O over A. But I know my O and my A, so I must be doing shift tan. Shift tan of theta equals what's my O? 23. What's my A? Solve that. Tell me what theta is. 57 degrees. Everybody cool? Now, if we do something once in math class and it works, what do we automatically know? That it'll always work. So let's go to this next question. Is there an angle in this question that I know about? 15. So do I have a theta? What is it? 15. Once I have theta, that means that's where I am looking at this triangle. So what is that? So my O is what? X. What's my A? 37. Tan theta equals O over A. What of that can I fill in? Tan of what's theta? 15 equals what's opposite? What's adjacent? How would I solve that in algebra? How would I get rid of divided by 37? Multiply by 37, right? So I multiply both sides by 37. What happens to these two 37s? Cancel, and I get x equals 37 times tan 15. What is it? 9.1? 9.9, so 10? 9.9 what? 9.91? So we'd do it as 9.9 because we round to one decimal. Tan 15, the way we'd already done it before, Nathan. 37 times tan 15 if you have a forward calculator. You don't have to do anything with the fraction here. I'm confused. You're getting rid of the 37 by multiplying. So you do 37 times tan 15 equals. Yes. Okay. Now, we've done this twice now in math. Will it always work? Good. What is my theta in this third one? 70. What is my opposite? 14. What is my adjacent? X. Tan theta equals O over A. What's theta? What's my O? 14. What's my A? X. Now you're intelligent young people. When the number was on the bottom, I multiplied. Now the number's on the top, so I divide. X equals 14 divided by tan 70. And what do you get? So 5.1. Please notice that trigonometry allowed us to find an angle, the length of a side, and the length of a side without ever actually measuring it. Everybody understand? Now, there is only 6 minutes left in class. You have no homework. You have nothing to do tonight except think about this. Tomorrow we're going to be doing work with this. Now listen to me carefully. If you are having trouble with this, you're going to have a lot of trouble tomorrow. Make sure you have at least a look at page 53, 54 tonight at home. That's your homework. Read over 54 and make sure you can get your calculator to show you the same answers we got as a class. If you wish to be ahead of the game tomorrow, you can do page 55. Okay? If you're feeling confident, do 55. If not, that's what we're going to spend the first 20 minutes doing tomorrow anyway.